Hey guys, welcome to this Chapter 10 test review. Let's take a look. First one, given the square root function, what is the transformation from the parent function? So first off, let's remember that our form is a times the square root of x minus h and then plus k. So when I see f of x equals square root of x minus 2 and then plus 1, I know that my a is 1. I know that my h is 2 and my k is positive 1. So 2 positive 1 is my hk. From that hk, I know that this means I go to the right 2, and then 1 means I go up 1. Because remember, the h value tells you if you're going left or right. If it's positive, you go to the right. If it's negative, you go to the left. And then the k tells you if you go up or down. So since it's plus 1, it's going up 1. If it was minus 1, it would go down 1. So right 2, up 1. Next one, number 2, determine the square root function from the graph. So here's kind of like the opposite idea. What I want to do is I want to see what's the vertex, what's my hk. So when I look at this, I see that my vertex is at -2, -3. Okay, so -2, -3. So let's say I have my f of x equals the square root, a times the square root of x minus h, and then plus k, and I plug those numbers in. I get f of x equals square root x minus, my h value is -2, and then I have minus 3 at the end for my k because this is my hk. So what this will look like is f of x equals square root of x plus 2 and then minus 3. So square root of x plus 2 minus 3 is my answer. Okay, number 3, simplify the expression. So what we learned with radicals is that you have to simplify by breaking down a number with the biggest perfect square. So my perfect square lists 1, 4, 9, 16, 25, 36, 49, 64, and so on. 81, well, 81 doesn't divide into 90, 64, no, 49, no, 36, no, 25, no, 16, no, but 9, yeah. 90 breaks up into radical 9 times radical 10. And I know 9 is good because can you break down 10? No. Radicals are always broken down into a perfect square and a non-perfect square. And we know the square root of 9, it's 3, but we don't know the square root of 10. And so that's our final answer, 3 radical 10. Number 4, which radical expression cannot be simplified? Ooh, so these are good. So radical 19, I have radical 40, I have radical 84, and I have radical 27. All right, so 19, my list, right? 1, 4, 9, 16. Doesn't look like 19 is divisible by any of those. Let me check the rest. 40, 40 is divisible by 4. It's radical 4, radical 10, which is 2 radical 10. So that one can get broken down. 84 is also divisible by 4. It's radical 4 times radical 21, which is 2 radical 21. 27 is not divisible by 4, but it is divisible by 9. So that would be radical 9, radical 3, which is 3 radical 3. So the only one that cannot be simplified further is radical 19. Okay, number 5. So ready? Number 5 is all about variables, rather. So square root of x to the 4th, y to the 5th, z. Now, when we do this, we want to do each part separately, individually, okay? So when I take the square root of x to the 4th, that's easy, because can you take half of 4? Half of 4 is 2. And that's all that happens when you take the square root of a variable with an exponent. But 5, I can't take half of 5. So here's what happens. With odd exponents, we take 1 away. Because what's 5 minus 1? 4. Can I take the square root of y to the 4th? Absolutely. So what we do is we break this apart into square root of y to the 4th, square root of y to the first power. We break 1 away because now look, we're going to be able to simplify that in just a moment. And then square root of z is just square root z. When you have a square root of a number to the first power, you have to just leave it under the radical. So now this becomes x to the 2nd. I can now take the square root of y to the 4th. The square root of y to the 4th would be y to the 2nd. But square root y is going to stay square root y, and square root z will stay square root z. Final answer, x squared, y squared, and then square root y, square root z get to share one radical. It's like they're sharing an umbrella, and that's my final answer. So x squared, y squared, square root yz. Number 6, find the area of a rectangle with the given dimensions. So rectangle, we know area formula is length times width. So really all I'm doing here is I'm doing 2 radical 10 times 3 radical 6. Okay, multiplying radicals is no big deal. I multiply my numbers out front, so 2 times 3 is 6. And then I have to multiply my radicals together. Radical 10 times radical 6 is radical 60. But I know this is not a simplified answer. I need to break this down further. So 60, what perfect square goes into 60? So is it 1, 4, 9, 16, 25, 36, 49? It is 4. 4 is the biggest one. So 60 gets broken down into radical 4 times radical 4 times 15 is 60. This then becomes 6 times 2, because the square root of 4 is 2, radical 15. And what's 6 times 2? 6 times 2 is 12. And so my final answer is 12 radical 15. Okay. Number 7, find the perimeter of a triangle that has that same length and width. Now, perimeter is different. Remember, 3rd grade, perimeter is you just add up all the sides. So if I know that I have a length of 2 radical 10 and a width of 3 radical 6, well, I also know that the bottom is then 2 radical 10 and the other side is 3 radical 6, right? Properties of a rectangle, opposite sides are congruent. And perimeters just add these all up. So I have to do 3 radical 6 plus 3 radical 6 plus 2 radical 10 plus 2 radical 10. And what we have to remember is that when we add radicals, we can only add radicals that have the same radicand. So 3 radical 6 plus 3 radical 6 would be 6 radical 6. You don't actually add the radicands together. You just do the coefficients. Plus 2 radical 10 plus 2 radical 10 is just 4 radical 10. And that is it. I cannot go any further because they are unlike radicands. And that's my final answer. And notice that my answer choice is actually in reverse because the order will not matter here. Number 8, simplify the expression. So good, this is more practice of just combining like terms. So 2 radical 7 minus 5 radical 3 plus 4 radical 7 minus radical 3. I can combine my radical 7, so 2 radical 7 plus 4 radical 7 is 6 radical 7. Negative 5 radical 3 minus 1 radical 3 is negative 6 radical 3. Easy, easy. Number 9. Now, at first sight, number 9 looks crazy. Like they all have different radicands. I can't add or subtract these, so what do I even do? But we're going to use our simplifying method to help us break this down so that we can add and subtract. So the first one becomes 4, 20. How do you break apart 20? That would be radical 4 times radical 5 plus 3. 75, what perfect square goes into 75? It's 25. So this is radical 25, radical 3. Minus 2, radical 27. What perfect square goes into 27? 9. So that's radical 9, radical 3. All right, so now I need to simplify all of my perfect squares. So this is now 4 times 2, radical 5, plus 3 times 5, radical 3, minus 2 times 3, radical 3. 4 times 2 is 8, so I have 8 radical 5, plus 3 times 5 is 15, radical 3, minus 2 times 3 is 6 radical 3. Now the only last step is here. I can combine 15 radical 3 and negative 6 radical 3. So final answer, 8 radical 5 plus, what's 15 minus 6? It's 9, 9 radical 3. That's it, 8 radical 5 plus 9 radical 3. Number 10, simplifying. So we have a bunch of distributing to do here. So we are going to look at 2 plus radical 5 times 3 minus radical 2. Okay, so just like we did 2 chapters ago, a binomial times a binomial, we distribute this all out. So I first do 2 times 3. 2 times 3 is 6. Then I do 2 times negative radical 2, which is negative 2 radical 2. I then have to distribute my radical 5. So radical 5 times 3 is plus 3 radical 5. And then radical 5 times negative radical 2 is negative radical 10. Doesn't look like I can simplify any of these. Radical 2 can't be broken down, radical 5, radical 10. They're not like radicands, and so I'm actually just done. And the answer choice that matches my answer is the last one. I don't know why the answer choices have been the last one each time. That's so crazy. And that's my answer. Number 11, simplify the expression. Okay, so what we learned is that when you take the square root of a fraction, you are really taking the square root of the numerator over the square root of the denominator. Now, unlucky for us, square root of 2 over square root of 3 can't be broken down or simplified, but there is a rule. We are not allowed to have radicals in the denominator. So what we have to do is rationalize. And when we rationalize, that means we multiply this fraction by a brand new fraction made up of that radical that was in the denominator. So it's going to be radical 3 over radical 3. Now here's the cool part. Here's what happens. Ready? Radical 2 times radical 3 is radical 6. Radical 3 times radical 3 is radical 9, which we know. We know the square root of 9. It's 3. And so my final answer becomes radical 6 over 3. And there's no longer a radical in the denominator. Perfect. Number 12, solve the radical equation. Okay. Square root of x plus 6 and then minus 1 equals 4. Step 1 in solving a radical equation is to isolate the radical, get the radical by itself. I see that this radical has a minus 1 at the end, so let's get rid of that minus 1 by adding 1 on both sides. We get the square root of x plus 6 equals 5. Now, once the radical is isolated, the opposite of square rooting something is to square it. So we are going to then square the left-hand side, and we are going to set that equal to squaring the right-hand side. Now, the reason why we do this is that the square root and squared operations are opposite operations, and so you're just then left with x plus 6 equals 5 squared, which is 25. Let's go ahead and subtract 6 on both sides, and we end up getting x equals 19. Now, it would be silly to solve any equation ever and not check it. These are so easy to check. So when you take 19 and you go back and plug it in for x, what's 19 plus 6? 25. What is the square root of 25? 5. And is 5 minus 1, does that give you 4? Yes. If it gives you a true statement, you know you're good. It's crazy not to check. Next one, square root of x minus 3 equals negative 5. Now, first of all, can the square root of anything ever be negative? No. Like, this is not possible. The square root of any real number cannot be negative. Maybe in algebra 2 they can be negative, but in algebra 1, square root of any number, any real number is a positive value. So right immediately, red flag, this is going to be no solution. I'll tell you right away, it's no solution. However, I know that sometimes as students, we don't see that. And so let's say we just went with the flow and we did exactly what we did for the last problem. Oh, the radical's by itself. Oh, okay, let me square both sides. So square root of x minus 3 squared equals negative 5 squared. And then you're like, okay, cool. This leaves me with x minus 3 equals 25. Let me go ahead and add 3 on both sides. You do plus 3, and you end up getting x equals 28. But look what would happen if you plug this in. If I took 28 and I plugged it in, what's 28 minus 3? 25. What's the square root of 25? It's just 5. Does 5 equal negative 5? No, they don't equal each other. It will not work out. And so that would be the second way to make sure that you know it's no solution, but you have to check your answer in order for that to be able to happen. I have one more radical equation for us to do, and this last one is the one that is the most complicated. It has the most steps. So if I take the square root of x plus 2 and I set that equal to x minus 4, is my radical isolated? Yes. Is it equal to a negative? No. So I know I could do this problem. I'm going to square both sides. And so if I square both sides, I am then left with x plus 2 equals. Now, squaring a binomial, the long way would be to do x minus 4 times x minus 4 and do all the distributing and then combine like terms. Faster way is this pattern. Excuse me. You square the first term. If I square the first term, I get x squared. Okay. The way I get the next term is I multiply x times negative 4. What's x times negative 4? It's negative 4x. And then you double it. What's negative 4x doubled? It's negative 8x. And then you square the last term. So we squared the first term, got x squared. We multiplied x times negative 4, got negative 4x. You double it. That's how you get the middle term. Last term, you square the 4 at the end, and 4 squared is 16. Now, if you're like, I will not remember that pattern, you would just do x minus 4 times x minus 4, distribute this all out, combine like terms, and you're just going to get this as the same answer anyway. Step 1 in solving a polynomial equation, set it equal to 0. So I'm going to go ahead and subtract x on both sides. So I get 2 equals x squared minus 9x plus 16. Still have to Subtract 2 on both sides. I'm trying to get this equation to be equal to 0 because that's the first step in solving any quadratic or polynomial equation. So then I would ask you what two numbers in this easy trinomial, what two numbers multiply to get 14 that add up to get negative 9? Is it 1 and 14? No. Is it 2 and 7? Yeah. What kind of 2 and 7 will get you a negative 9? Both negative. So this is x minus 2, x minus 7. Last step, set each factor equal to 0. So x minus 2 gets set equal to 0. X minus 7 gets set equal to 0. And I end up getting x equals 2 and x equals 7. But I do have to be careful because sometimes there's extraneous solutions. And the only way to figure that out is to go back and plug it in back into the original equation. So I have to see, does it check out? So here's what happens. I go and I plug in my 2. Ready? If I plug in a 2 in for x into both of these spots, the original problem, what's 2 plus 2? 4. What's the square root of 4? 2. Okay, well, what happens when I plug in a 2 over on the right? What's 2 minus 4? It's negative 2. Does 2 equal negative 2? No, and so 2 actually doesn't work. It's extraneous. 7. If I plug a 7 in, what's 7 plus 2? 9. Square root of 9 is 3. And what happens when I plug that same 7 over here on the right? 7 minus 4 is also 3. So 7 is my only solution. That's it. Number 15, Pythagorean theorem. Find the length of a leg of a right triangle. Find the length of a leg of a right triangle. So one of my legs is missing. If one leg is 9 and the hypotenuse is 16. Ready? A squared plus b squared equals c squared. So I know I'm solving for a leg, so a squared plus, I know the other leg is 9, so 9 squared equals, c is my hypotenuse, 16 squared. This ends up becoming a squared plus 9 squared is 81, equals 16 squared is 256. I want to solve for a squared, so I go ahead and subtract 81 on both sides. I end up getting a squared equals 175. I then need to take the square root on both sides because we don't want a squared, we just want a. Okay, and when I go and do that, I'm able to simplify out my radical and my squared. I'm left with a equals, now 175 is not a perfect square. Biggest perfect square that goes into 175 is 25. So this would be radical 25 times radical 7, which then becomes 5 radical 7. And that is my answer, 5 radical 7. Number 16, find the length of the hypotenuse of a right triangle. If the legs, so now I need to find, okay, the hypotenuse C, if the legs have a length of radical 10 and radical 3. Okay, so a squared plus b squared equals c squared. Now it doesn't matter which one is a or b, that doesn't matter. So if I say a is radical 10, but I have to take radical 10 and square it, plus b is radical 3, and I have to square it, equals c squared. Now this is going to work out really nicely because what's radical 10 squared? It's just 10. Plus what's radical 3 squared? It's just 3, equals c squared. 10 plus 3 is 13, equals c squared. How do I undo the squared? I take the square root of both sides, and when I do that, I'm left with the square root of 13 equals c, and 13 can't be broken down. That's just my final answer. Number 17, do the sides of 15, 20, and 25 form a right triangle? So the only way to know if 3 side lengths form a right triangle is if they actually work for a squared plus b squared equals c squared. So I want to check, does 15 squared plus 20 squared equal 25 squared? That's what I'm checking. And I know 25 goes in for c because c is the hypotenuse, and the hypotenuse is the largest side of a triangle, right triangle. So 15 squared is 225. Plus 20 squared is 400, and 25 squared is 625. And look what happens here. 225 plus 400 is 625, and 625 does equal 625, so the answer is yes. Now, another way to actually look at this is what are 15, 20, and 25 all divisible by? They're all divisible by 5. So what would happen if I divided each one of those by 5? Guess what I'd get? 15 divided by 5 is 3. 20 divided by 5 is 4, And 25 divided by 5 is 5. And guess what? 3, 4, 5 is a Pythagorean triple, and any multiple of a Pythagorean triple makes a right triangle. So even just seeing that correlation would tell me that was the answer without even doing any of the math. Number 18, another question. Do the sides of 7, 8, and 15 form a right triangle? So I want to check, does 7 squared plus 8 squared, does it equal 15 squared? Well, 7 squared is 49, 8 squared is 64, 15 squared is 225. Now, 49 and 64 definitely don't equal anything over 200. If I add those up, 49 plus 64, I would get 3, carry the 1, 113. And that definitely does not equal 225. So those do not form a right triangle at all. Last two questions are about distance formula and midpoint. So distance formula, long formula. But if you're given the ordered pairs of x sub 1, y sub 1, and x sub 2, y sub 2, the formula is that you take the big square root of, you subtract your x values, so x sub 2 minus x sub 1, and you square it. Plus, you subtract your y value, so you do y sub 2 minus y sub 1, and you square it. So you subtract the x's, square it. Subtract the y's, square it. Add them up, and then take the square root. Now, the ordered pairs that I have here are 4, 6, and negative 3, 5. And I just have to plug my numbers into this formula very carefully. So this would be, what's my x sub 2? My x sub 2 is negative 3. So negative 3 minus, my x sub 1 is 4, close parentheses, squared. Plus, now I have to do y sub 2 minus y sub 1. So 5 minus 6, and then I have to square it. Okay, so now this is d equals square root. What's negative 3 minus 4? It's negative 7 squared, plus 5 minus 6 is negative 1 squared. Now we know when you square a negative, you get a positive answer. So negative 7 squared is 49. Negative 1 squared is 1. What's 49 plus 1? It is 50. Now 50 is not a perfect square, but can we break that down? Absolutely. Square root of 50 gets broken down into radical 25, radical 2, which is simply 5 radical 2. And that's my answer. Last one, midpoint. So same ordered pairs, but to find the midpoint. So the midpoint formula is where you take the x's, you add them up, divide by 2. That's just the average of the x's. Take the x values, add them up, divide by 2. And then you just simply take the average of the y values. You add those up and also divide by 2. The middle is just the average of the extremes. So I take my x values, add them up, divide by 2, I get the middle. I take my y values, add them up, divide by 2, I get the middle that way, and that's going to be my midpoint. So my ordered pairs were 4, 6, negative 3, negative 5, right? Positive 5. So x sub 1, y sub 1, x sub 2, y sub 2. So I just simply plug this in. So my midpoint would be, I add my x's, so 4 plus negative 3. I know double signs are ugly, just deal with me on this. And then y sub 1 plus y sub 2. So 6 plus 5 over 2. So now I'm just going to simplify this out. I'm going to get my answer. So let's see, the midpoint, 4 plus negative 3 is 1 over 2. 6 plus 5 is 11 over 2. Now I see I have decimal answers. No big deal. Fractions are good. Decimals are good. Well, half is just 0.5. And 11 divided by 2 is 5.5. And again, fractions or decimals are all good. And I have my final answer. I hope this was helpful. Good luck on your test. Bye.